Okay, now that you've read it once, and this is sometimes how math works when we read, okay, you'll find that you read very, very well right now, and if you go into the math and sciences, and my husband and I are both the same way, you go to college and you have to reread the thing like 4 times to understand it, that you start slowing down when you read, okay? So, it's the future for some of us, and that's okay. All right, so I want you to read it again and answer those questions. So on the top of your notes, those questions are typed there. So you need to answer those at the top of your notes. So everybody's going to do this again. Okay, read it a second time and answer those questions. I'm going to give you about 2 or 3 minutes to do that. So write down your answers as you get them. About another minute. All right, so let's talk about the answers to those questions, okay? Because everybody read the same thing. Okay, we should all hopefully have gotten some kind of an answer there, okay? So what we're talking about today is the logistic equation, okay? So we're going to actually try to take that logistic differential and come up with a more general solution for it today. That's kind of our goal. If we can get through that, then we can finish this tomorrow if I have to, okay? So what is the carrying capacity? What did it say? Okay, it is the L. I know that. What was it specifically, though? It was the max population, right? So, and it's important that you know that the carrying capacity is L. All right? And you guys, a lot of what we do here, we're aiming to answer a question, being able to answer 1 or 2 questions on this on the AP test. More likely on the multiple choice. Okay, this is where these pop up. So what's the difference between exponential growth and logistic growth? Exponential growth what? Okay, so it's unlimited, no limit on exponential. And then what about the logistic? there's an upper limit to, or there is a limit to it, right? So logistic growth has a limit, exponential growth has no limit. Did you guys see that picture off to the left side? And that's the other thing about math and science. There's lots of pictures and graphs and stuff, and you want to be able to make sure you know those. See how that picture, that's a logistic curve, how it levels off, so that there had to be some kind of a limit on that. Okay, now there is a typo in some of the books. Were some of your books written in? I don't know if they, some of the kids, of course I have a different class set this year. So some of the books had a typo in it, so we'll see if that typo is in some of your books, okay? When does the population increase? dy dt was what? Greater than 0, which means what? What's greater than 0 mean? Positive. So when the population is increasing, when dy dt is positive, okay? It also said something about the limit, didn't it? If y is... Oh, it also said that y had to be between 0 and L, the carrying capacity. Okay? So when does the population decrease then? When what's negative? The derivative. dy dt is less than 0 or negative. That means that y is what? Greater. Did anybody have a k in their book instead of the L? Edit that. It shouldn't be a k, it should be a y. Does everybody see? There's some people, it was bizarre. My book says a y. Some of the books in the class said a y last year and some said a k. I don't know what happened. Must be one run of the book versus the other. So I know that at one point we had a small calculus group and then we kept increasing. So maybe the old ones had the k in it. I don't know. And they all got mixed up. So, all right. So that is kind of some basics about the logistic equation. All right. We've done our little closed reading assignment. So we've satisfied R of Wicker, right? I just got that in. We do that not very often in math. Okay. All right. So our goal for this here today, and you have a lot of space to write, correct? Okay. So what we're going to do is we're going to take that logistic differential and we're going to turn it into a function today. If we can get through that and you don't whine and complain about it, I'll be really, really happy. Okay? So, before we get too far into it, okay, the P in there, so I'm going to write down what it kind of stands for and you're going to see it translate. Oh, notice in your book it's Y's, right? Yeah. I'm going to change the Y's to P's. Because in every single book, so these are actually, I'm going to turn into P's. Okay, and he's going to turn these into P's too. In every single book, they give you a similar equation, but they have different letters in it. All right, so we're going to use this one even though it doesn't match our book. Okay, so because P made more sense because it stands for the population. So P stands for population at time t. Okay. K is what we call the constant of proportionality. Okay. Is there a box for you to fill this in? I'm not looking at your...
No, it's like a big box.
Oh, it's a big box. Nice. Okay. And so I actually had it there. And then L we already know is what? What did we learn? The carrying proportionality. L is the carrying capacity. I can spell capacity right. All right, so you guys had a box there. I didn't have the box in the PowerPoint here. Okay, so we've got a lot of space. Basically what we're going to do is a proof, okay? But we're going to use algebra to do the proof. We're not doing the if and the then and the two columns, okay? All right, so we're going to go slow. We're going to try to make sure we all understand. Do I have it? Yeah, I've got a bunch of screens of that. Okay. All right, so we're going to try to understand how we get from here to the logistic equation, okay? Because this is the logistic differential. First thing I'm going to do is I'm going to separate my variables. All right, we've all done that before. Okay. This has the p's in it. Notice I'm integrating with respect to time, and I have a p as my variable. So I'm going to take this chunk with the p and move it to the other side. It's right now under multiplication. So how do I move it to the other side? We divide it. Good. So I'm going to put 1 over p times 1 minus p over L. That's an L, not a 4. L. dp equals, the only thing that got left on the right side was a k, and then we're going to multiply over the dt. Okay. So now we're supposed to integrate that. This looks awfully fun to integrate, doesn't it? Yeah, okay, so we got to work on that a little bit. Okay, so here's what I want you to do. Okay, you know how we have that left-hand column? You're not going to continue your work here. You're going to go into that left-hand column, and we're going to do some side work. Okay, so I'm going to go to another screen to do that side work. Okay, so in order to deal with this guy, all I'm going to deal with is this chunk in here. I'm going to rewrite that so it's something we can integrate. And we're going to use partial fractions. Okay, so write this in the left-hand column. So this is your left-hand column. Write it on this side of it. Okay, got it? So we're going to start with, it was 1 over p times 1 minus p over L. Okay, I want to get rid of that denominator. So how would we get rid of that denominator? We got to multiply by L, right? Yeah. If we multiply by L, we're not changing it. So if I multiply by the top and bottom by L over L, I'm not changing the equation. I'll be able to cancel that L. Okay, here comes one of the weird parts. Okay, I'm going to do some algebra, but not all the way. Okay, the top is just going to stay L. Okay, the bottom, I'm only going to distribute the L in. I'm not distributing P because I don't want to have to factor. Okay, so I'm trying to shortcut it by making it look weird. So L times 1 is L. We've got P over L times L is going to be what? P. Okay, are we all okay with my algebra so far? I'm going really, really slow on this today. Okay, all right, now we're going to do our partial fraction off of that. So what are my two denominators? Oops, what are the two denominators that I would write? P and L minus P. P, L minus P. And on the top we would write A, B. Have you noticed there's no numbers? It's one of those great days where there's no numbers in the problem. Okay. All right. So we're going to now do our again, we're doing partial fractions like we did yesterday. That's why I taught it yesterday. So this one, we multiply by the common denominator, P times L minus P, and it would cancel. We would just be left with L. Okay. This one we would multiply by L minus P, right? So we would have AL minus AP. What would we multiply this B by? P, because that's what's missing, right? All we're doing, even though it's all letters, we're following the rules we followed yesterday. Okay? Now we're going to look at our coefficients. How many P's do I have on the left side? 0 P's, right? Okay, so let's look at... Let's switch to a different color here. I'm just going to look at the L's. So what would my L equation be? Again, ignore the L is the variable. Okay? 1 equals A. Perfect. All right, now let's do a P equation. So what would my P equation be? A plus B. The P is acting like a variable as well. Okay? All right. Huh? No, there's no constant equation this time. Okay? It was an L equation and a P equation. All right, so I already know what A is, so I'm going to plug that into this one, aren't I? And solve for B. So -1 plus B, so B is equal to 1. So if I went to rewrite this, I would have a 1 in there for the A and a 1 in there for the B. Okay, so now I'm going to go back to my other screen. So now you're going back to the work we were doing. We are going to replace this, okay? Instead of the way it looks, I'm going to replace it with 1 over P plus 1 over L minus P. dP equals K dt. I am going to go ahead and split this into 2 integrals and put a dP here because of the way we have to integrate it. Okay. All right, so let's see what we can do to integrate that now. All right. So when I integrate 1 over P, what do we end up with? Natural log, absolute value of P. Okay, we have to be careful. What are we integrating with respect to? P, right? So that means P is the variable, L is acting like a constant. So if I think of P as the variable, don't I need a U substitution? There's a lot of junk going on here, so we're not going to do a full U substitution. It's the first time I'm going to shortcut it for you. Okay, let's just figure out what's missing. So we know L is a number, L is a constant. When I take the derivative of negative P, what do we get? Be negative dP, right? So the only thing I'm missing here is what? A negative. I don't need to write a U in to just add a negative in here, do I? Add the negative in. Okay, I can get rid of my plus sign, make it a negative. Okay? So, I did a U substitution, but I didn't write down all the U mess. Alright, because when we integrate this, it's going to end up being what? Natural log of U, right? And instead of U, what would I write? L minus P. We shouldn't need a U substitution for our natural log, okay? All we need to do is figure out what's missing, okay? And put that and pop that into the function, okay? All right, equals, when I integrate K, what do we get? Or K dt, what do we get? KT, perfect, plus, or C sub 1, okay? All right, let's see what we can do to clean this up a little bit. Okay, I'm going to do something here on this next step because I know that what the function needs to turn out to look like in the end. So I'm kind of playing that game right now. I'm going to distribute, and there's no necessary rhyme or reason for this, but it's to get things in the right order. I'm going to distribute a negative through this. Okay, so that would end up making it negative natural log absolute value of P plus the natural log absolute value of L minus P, and it's going through the whole thing. Negative KT and negative C sub 1, which is still just C, isn't it? All right. I don't like the order that that's written in. We typically don't like that. Now we like the natural log, the minus, to be second. So all I'm going to do in this step is reverse the order. Again, it's not a hard step. It's just making it a little bit longer on us. Negative KT minus C sub 1. All right, think about what we've done with separation of variables. How do we get rid of natural logs? Ease. Okay, before I do that though, could I combine these logs together using my log properties? What does subtraction turn into? Division. So I really have L minus P over P equals negative KT minus C sub 1. Okay, I'm going to give you a minute. I want you to make sure you get it all written. I'm going to go to a different screen. You know it's bad when I have to use 2 screens, right? Yeah.
I still don't understand why you distributed the negative.
A negative? Because ultimately in my final equation that I'm trying to get to, I need that P in the denominator.
Oh.
The only way to force that was to switch where these guys were, right? It doesn't change the equation if I multiply the whole thing. Okay? All right, and like I said, that step was kind of, you have to take my word for it working, okay? It's one of those experience things, right? When the more experience we get, the better we get at recognizing when that needs to happen, okay? And again, what we're doing right now, you guys, we're proving a formula. I'm not going to put this on a test, okay? This is one of those rite of passage in calculus kind of things that we got to do. It's good for us to see these because you get more experience. You get better at this when you go see a college professor does this with you. You've got it, okay? A lot of college math classes, your homework is doing proofs, okay? So beyond the calculus ones not so much, but when you do more algebra ones, that's what happens. Okay, I'm going to another screen. Everybody okay with that? Everybody has this all written? Okay, so I've got to skip down to here. All right, so the next thing I'm going to do is I'm going to use the e, right, to get rid of my natural log. So I have e to the natural log of the absolute value of L minus P over P equals e to the negative kt plus, it wasn't plus, it was minus c sub 1. All right, what happens with the e and the natural log? They cancel. Good. Okay, so I'm left with the absolute value of L minus P over P equals E. Okay, now what do we know about this E and the minus thing here? Can't I convert that into, because isn't it same thing as plus and negative? So remember what we were doing earlier in the week? We had negative E to the KT and E to the C sub 1. So what does this ultimately turn into right here? A constant, right? So can't I just rewrite this as CE to the negative KT? I skipped like 3 steps though, didn't I? To go from here to here. Okay? At some point, you're just going to recognize that. You're in a more advanced class this year. You're going to recognize when you see that it's just going to become a constant. Okay? All right. What we want to ultimately get this down to is we want to solve for P. Okay? So I'm trying to get it as a P equals right now. So, how do we undo the absolute values? Do you guys know? Plus minus undoes an absolute value. Okay, so we're going to put a plus minus over there. All right, I'm going to pull this fraction apart now because again, I'm trying to get it down to P equals something. So I've got L over P minus P over P. Well, what's P over P? 1. Okay, so I'm just going to scribble a 1 on top. I'm not going to rewrite that line just for that. How do we take that 1 and move it to the other side? We're going to add it. So plus or minus CE to the negative KT plus 1. All right. We need to... Okay, I'm going to do something. Let's see, what did they do next here? Yes, I did that. Okay. I want that P upstairs, don't I? Okay, watch this fancy footwork here. P over L equals 1 over plus or minus CE to the negative. What did I do to both sides? I reciprocaled both sides. We've probably never seen that happen before. So go ahead and reciprocate. You can do that. Reciprocal both sides.
Yesterday in physics.
Oh, did you see it yesterday in physics?
Yeah.
Great. Cross-curricular. All right, and then how do I get P by itself? Yeah, multiply by L. So we get P equals, that plus or minus could probably float in front. L over CE to the negative KT plus 1. Okay? The only thing that's different about this and the formula we're going to use is we're going to let C equal A and plop an A in there. AE to the negative K. You did no whining whatsoever. That was good. So that's what we're ultimately getting. So what we did was we started with the differential. This is what the general equation looks like.
I don't think we won because you said you wouldn't put it on a test.
I wouldn't put it on a test. That's good. Yeah, you should have heard, even though when I told, because I was watching the video of me doing this last year with my group last year, and they whined through the whole thing. You should have heard them. I could hear Manny and Tuttle in the background, and oh, yes. All right, he liked to whine. Okay, so.
Did you have his brother?
No, I never had the brother. I only had him. So, does he have another brother coming up?
Yeah, he's the younger.
He's what?
Is he a freshman this year?
Yeah, somebody said they had a Tuttle on the list, but I wasn't sure if they were related. So, all right. How are we doing on time?
Pilcher too.
30. What?
Pilcher.
There's another Pilcher?
Yep, his brother's a freshman.
Oh.
I heard his name in during passing period the other day. I was like,
Oh, really?
he's not here.
Yeah.
And this little just like
32. Okay.
they're like twins.
They're like, there's two of them?
No, they look like twins.
Oh, they look like twins? Yeah.
The hair is all curly and everything's like crazy.
All right. How are we doing with this so far? Okay. So, all we had to do was prove it. Okay? And as long as you understood the steps kind of as we were doing it, you don't have to go back and recreate it anywhere. So you should have, is this on your paper somewhere? Flip to the next page. Is it that there? No. Okay. So somewhere on there you probably want to label, okay, that this is the logistic differential. And this one is the logistic equation. Do you see that there's similarities in the letters? Okay. So if I give you an L here, that carrying capacity could transfer over here to this carrying capacity. Okay. The K values are the same thing. All right. So they sometimes will give us a function that looks in this format and we have to get it into this format. Okay. Depends on what they're asking us for. Okay. All right. So let's see if we can do at least example. Oh, there's only 2 examples, huh? All right. Let's look at example 2. The homework assignment that goes with this is super short. So that usually means it's harder, although I don't think it's any harder than normal. So I even tell you which problems in the book this is like. So it's like 71, 72. Logistic differential equation. So that's telling you you're using a logistic equation right there in the instructions. Okay, so we're using the logistic equation. It models the growth rate of a population. Use the equation to find A, the value of K, B, the carrying capacity, C, initial population, D, determine when the population will I think that should say will reach, not with reach. Will reach 50% of its carrying capacity, and write the logistic differential equation that is the solution to P of T. Okay? So, the first thing I'm going to do is try to fill in, oh, I think there was something missing. Logistic differential equation. Let me double check and make sure. 71, 72. I think I missed typing something. 6, 6. This is 6. Yes, it is. Oh, 6, 3. Here we go. Number 72. Yes, I forgot to give you the function. So you got to write the function down. P of T equals 2. It helps to have the function 2000 over 1 plus 19 e to the negative 0.55 t. So it will give you a function. It gives you this big chunk of instructions and a function for each one of the problems, okay, that you have to do. All right, so part A says 55t, yes. It says find the value of what? It says find the value of K. All right, compare this to the function we just wrote down. What's the K value? Can't you just read it out of there? It's 0.55. Why is it not negative 0.55? Yeah, it's negative in the formula, so we don't need the negative there. Okay, so the negative doesn't get translated to the K value. All right, B is asking us for the carrying capacity, and the carrying capacity is equal to L. So what's the carrying capacity of that one?
2000.
Where are we getting that from?
The top.
Yeah, the numerator, the top, right? And that L was part of the formula that we just had written down. All right, now it says find the initial population. Okay, so I'm trying to figure out when so the initial population, what would the time have been? 0. So we're going to put a 0 into that function. So P of 0 equals 2000 over 1 plus 19e to the negative 0.55 times 0. All right, what is, this turns, negative 0.55 times 0 is what?
0.
Anything to the 0 power is? 1. So I've got 2000 over 20. So what does that reduce to?
20. No, 200.
No. 100 is our initial population, right? Because 2 into 200 is 100. All right, we all with me on C? Okay. Now it wants us to know when, so D, determine when the population will reach 50% of its carrying capacity. How much is 50% of its carrying capacity? Half. What is the max carrying capacity? So what's half of its carrying capacity? So you're going to set up the function exactly the way it looks, and we've got to solve for the time, right? Because it says it wants to know when the population will reach 50% of its carrying capacity. So I'm going to do 1,000 equals 2,000 over 1 plus 19e to the negative 0.55t. All right, how are we going to solve that? What should I do? Could I do one of these guys? Yeah, could I cross multiply it? That's always okay to do, right? So, or we multiply by the denominator, same thing. All right, so I end up with 1,000. I'm not going to distribute that at this point. Negative 0.55t equals 2,000. All right, how do I get the 1,000 over to the other side? Divide it. I wouldn't distribute it in. It's going to cause you more trouble than it's worth. Okay? 0.55t equals, let's see, 2,000 divided by 1,000 is? 2. So now it's algebra that we've seen before. All right, what are we going to do with that 1 to move it over? Subtract it. Good. And you get 1. Okay, Kaylee says divide by 19. Are we all with her? We should just let her teach it today. Okay, what do I need to do to get rid of the e? We're gonna now, I'm just going to do it in that line rather than rewriting. I'm going to be a little bit lazy. So that's going to get rid of this here. So I've got negative 0.55t equals the natural log of 1 over 19. What do I need to do to get this to the other side? Divide it. Okay, so here's where your calculator comes in, right? Negative 0.55. All right. You punch the buttons and tell me what you end up with. Five. Are we agreeing with Kaylee? Cora nods not in her head. Yes. Anybody else? Yes. Yeah? Okay. So we got our time. All right. Part E is asking us to find the logistic differential equation that has this solution. So all we fill in on the logistic differential is the K and the L. So look back at this function here, right? We're going to fill that thing in. So all I put in is the K and the L. You ready? So we do dp over dt equals, what's your k? Didn't we write it down earlier? 0.55, not negative, right? Just 0.55. P times 1 minus p over L. What's your L? 2,000. Done. So that was the, we have a million parts to this, right?
Wait, can you like box in E?
You want me to box in E for you?
Yeah.
Did that help?
So you just have to rewrite it?
Okay, so we started with this function. They wanted us to rewrite it as the logistic differential.
Okay.
So the good news is we didn't have to try to take the derivative of it to get there because we had a formula. So basically this formula and this are equivalent things, aren't they? One's the differential of the other, and they're interchangeable. So you can use the numbers from this and plop them into this and vice versa. Okay? Depending upon what they're asking you. Speaking of which, we're going to do that in the next problem here. Okay? What time do we get out at 48? Okay, let's do it quick. Let's get it done with. Okay? So, first thing, we see y's, where instead of y's, Mrs. Ballard told you to use p. Okay? All they want us to do is find the logistic equation that satisfies that initial condition. So I'm going to put it into this P equation that we had. Okay? What is the L, the carrying capacity for the top? 80, good, right? We read it right out of there. Okay? Then the function says 1 plus a e to the negative k. What's the k value from the logistic differential? 1.1 times the time. Okay? I need to satisfy that initial condition, right? So this is the time, that's the p. So I'm going to put this in just like we've done before. What am I going to put in for the p? 10 equals 80 over 1 plus a e to the negative 1.1. What's the time? 0. We've been doing that a lot. It ends up being e to the 0, which is what? 1. So we have 10 equals 80 over 1 plus a. Could I cross multiply it again or multiply by the denominator? So 10 times 1 plus a. I'm not going to distribute because isn't it easier to divide by the 10? So 80 divided by 10 is what? 8. So a is going to end up equaling what? 7. So we're going to fill back into this. So the whole point of what we did earlier in the lesson, that awful proof, was you can't use it until you can't use it until you've proven it, right? So we now can use it and not have to prove it ever again. Okay? And again, if you're going to see the book answer instead of a P there, they're going to say why. All right? Okay. It's homework number 13, right? There it is.